thank you for the introduction. So the challenge that we had at the client is that they were switching suppliers, and so operations engineers, and they had like 1 month, a couple of weeks to do the knowledge transfer. But the previous supplier was at the company for a lot of years, and they had to hand over knowledge about systems that were coded maybe 25 years ago, or like really a long time ago, and it were a lot of different systems. So a lot of different legacy systems that were not connected. And the new operation engineers, they needed to figure out, okay, if there is an issue, where is it? How do I solve it? And this was also for a system. Like this worked, so it was a stable, productionized running system, but it was big and it was complex. And so we had to develop a way to help the operational engineers, operations engineers, to very quickly onboard them and very quickly get to guide them to the correct solution if there was an issue. So again, the risk in the handover that we had was, so the people that knew something were all gone, which was a challenge. Then the documentation was also, because there is different sources of information. You have the code, you have configuration tables in SAP, where the client configured their processes. You have different languages, and then you have Confluence and other SharePoint and whatever. And often the written documentation was wrong, which was also challenging, which is why in the end we decided to focus on codes and on configuration tables, because we decided that's probably the most resemblant to the truth, to the actual truth. And we had a very hard deadline, which was the case. So, again, a little resume. So it took a lot of time. We had a knowledge void, and the engineers that tried to solve the issues at that point in time, they were more doing trial and error and actually understanding where they had to go. So how did we solve this? The decision was, okay, we're going to provide AI agents to all of the engineers, and the problems will be immediately solved. We will embed everything, and yeah, that will work. And it wasn't the worst approach. However, it immediately hit its limits because it was a lot of information, and it couldn't identify like sometimes a part of the issue, sometimes something that looked similar but was completely different, and never the entire issue, never the entire chain or process that was actually the issue. So the engineers, even if they find one point or several points, they had to manually bring everything together. And this brought us to Gross. And so this I already said. So embeddings allowed us to point to locations, but did not give us the entire chain that was actually needed for the solution. And what we then did is we created a graph where we still had embeddings, but we mapped the entire process. So we mapped from the configuration tables to where it called the code, and then we mapped the entire code, going from package to package, from system to system, so that if there was a question, that we could find an entry point using semantic search, but we also had Cypher templates for specific questions. That happened a lot, so that we could immediately find the exact spot where there was an issue, and then we could answer, okay, go to this system and do this query or change this code. And that will most likely solve the issue. So the impact of what we did there is we saved at least 30-40% of the time of the solution engineer. And sometimes with very simple cases, as in just like put it in, like renew the index there. It was from hours for finding the correct table to like 1 second, a couple of minutes to fix the issue. And also, and this was a very big point because cost savings is very important. We do not need a lot of tokens in order to come to proper solutions, which means which means it's a very cost efficient and fast solution. And so now we helped our operation engineers. Although we are in a very tight spot, we managed to get them all of the knowledge about these legacy systems, about these business processes. And then, okay, problem solved. But then we noticed there is actually broader benefits because now we had proper documentation. So we corrected all of the documentation that was in Confluence, which is the tool that they now use. We understood the systems that nobody understood anymore because even the previous engineers didn't really understand the 25-year-old system. So now our client Porsche is now in a stage where they understand these systems and therefore are now able to start migration projects, which was not possible before, or very, very costly. Also, the confidence in AI, but also in themselves, I think, of the AI of the operations engineer increased a lot. So they were confident that if they solve an issue, that they actually solve it, and that was basically the main point. We can do very rapid onboarding, not only for operation engineers, but generally for anyone new working on these systems. And those were like very big benefits for the client. And now I'll do a small technical deep dive. It's not as technical as what Christopher did before. The insight here is basically that knowledge, regardless of how it's represented, is a graph. Whether it's code, whether it's text, whether it's an issue ticket, you can connect it, you can destructure it into concepts, into relationships between those concepts, and form like, we now call it company brain. So there we noticed procedures in configuration tables called tables, or procedures in Oracle data warehouses. We can do even like temporal analyses based on the schedule that are set, which we didn't think about at the start. We can do causal analysis. We can do a lot of graph-based things now. And operations or supply chain, everything is a graph. This was really well understood at that part of Porsche. Not overall in Porsche maybe, but at that part of Porsche definitely. And it was nice. So what we built is first we created different ingestion pipelines for the different types of data, for the different languages that were needed, or for the different systems, because SAP or other like user-based systems, they all have different ways of structuring their data. So for every language, for every framework, we had to build our own ingestion pipeline, which all went into our graph. That was for us then basically the second layer, where we also did quality checks, where we could do a lot of like assurances that what is in the graph is correct. We basically went for like a shackle approach there, but then with Neo4j. And then on top of the graph, we created different agents that were specialized for different tasks. And then we created an operator interface, which was basically an orchestrator. And it would route a question to the relevant agent that then had different tools from which it could do specific tasks. Not like what was implemented at Siemens. And there we also did the hybrid approach. So we did not just use the graph, because I've also implemented the system where we did not use embeddings at all. It was full text search combined with Cypher templates. Also works very well. It's very fast and it's very cheap. It's cheaper. But here, because we really had to focus on the semantic meaning of the questions, we had to do the vector embedding approach as well. So embeddings could find places, like specific spots, but we did not have the entire structure, and we had the risk that because of not having the structure, we might be in the wrong process. The graph alone was quite good, but we needed the additional, the context, the meaning. We needed that to really pinpoint the correct starting points. And then together we had a system that really worked really well, saved a lot of time and saved a lot of money, and it was very easy to use. So any person who would start there can simply chat, and the system will be explained to it. If there is an issue, they can just copy paste the issue, and the answer would be go to this system. From the logs, we know there were like these errors, so now do this. And then he can immediately go there, he can read the logs himself, and then come to like an informed decision. The operation scenario that is there. So the operation engineers would put in the description of an issue. What they mainly do is they just copy paste the issue. The agent, which would be the operation interface, will decide what agent to use. And then the solution is found. And also if there is any documentation about this and it's now suddenly wrong again, it will also be flagged. And then the operation engineer has to check the documentation and fix it so that it again matches the code.
That's true.
So we have like this feedback loop. And this is one example of a ticket. And from this, our system can then figure out where something happened and how to fix it. I had to quickly go through there because, so what changed? Before, a lot of time needed to be invested. You really had to understand yourself what is the process, how does it work? And now the process is given to you. You ask the question. If there is a drift in documentation, if there is a drift in how the process should work and how it's working, it's immediately visible or relatively quickly. And everything becomes queryable, everything is traversable, and any person could choose to leave the company and be replaced by another person, and it would not be an issue. So it would really reduce the handover risk that companies face. So, again, so the handover risk, the delivery risk is that people have information in their heads, which needs to be handed over, and this we can now avoid with the graph. A graph is the better place to hold the knowledge because it's connected. It has all of the information. It has the process, the business process, and it's queryable, traversable, and operationally quite quickly useful. And that was my presentation.
Are there any questions for Maurits? Thank you for your presentation. How do you make sure that you don't use any information when transforming a structure or raw data to graph? So let's suppose we have a schema, data schema that is defined, and we have a change in the source of data.
Mhm.
Do you need to redesign the schema from scratch, or it is scalable and can be adapted to any new information now?
It depends on the source. Like if it comes from code, for example, we just replace it. We have we have different phases. Like we basically we create a new graph. We compare it to, or a subgraph. We compare it to the subgraph in the production database, and then we say, okay, does our new subgraph make sense, or do we lose too much information, or did something weird happen? And then we just replace the subgraph completely for that part. So not the entire graph. And that's how we do if there is no code information, then that's how we do it. And it works. It works really well because for code, our assumption is the code is the truth. So if it's there, it's the truth.
You can imagine, but
Have you measured KPIs like in the previous presentation? So that you made a stroke and that you have already first test results, what kind of efficiency or savings you have done?
Total savings, I have to ask the client. But the time that is saved, so the 30-40%, that's like an actual number. That's the average that is saved for every operations engineer in the time to resolution went down with 40%.
And in regard of the accuracy, how much time did you spend to create that kind of accuracy you needed?
Again, sorry?
The accuracy of the data, so when you talk to the data.
Yeah.
How much time did you spend on having that kind of results you need for the work, or that the customer needs for its work?
Great question. It's an ongoing process as well. So it's live, but especially for code, we use established packages to ingest it. If you use any IDE, in your IDE, the code is also transformed into a graph. Actually, that's how IntelliSense works. And we use basically that to ingest the code-based data, and that worked already really well. And all of we have not had the case that that a completely wrong answer was given. So like all of our questions, like our golden answer set, question set, they're all answered completely correct.
The advantage was to have a clear idea, so already something like that more structured data.
So the issue is that there's different. The biggest issue there was that there's different systems that call each other, that are connected, and that was the bigger benefit. So you don't have to figure out what the chain is.
it's got that. Please. Okay, cool. Thanks very much.